Now let's take a deeper look into our data warehouse and see what is in there. A data warehouse conceptually has four layers or four major components. First, data sources. Most of them coming from operational databases. Other resources that forms data sources through extract data, transform data, loading data, we put the data into the data storage layer. And the data storage layer going to be refreshed regularly, maybe every year, every 6 months, for example. Within this data storage layer, we can have a data warehouse that holds a lot of data cubes. And we also could, in place of a data warehouse, we could have smaller data structures that's similar to data warehouse, but not as comprehensive. We call them data marts. They support departmental functions. A data warehouse supports enterprise-wide functions, so we have all the data here. But data mart, you can think of them as mini data warehouse. That still supports OLAP operations, but they are smaller in scope, support more focused functions. Besides the data themselves, another very important piece of information is the metadata about data warehouse. We're going to have a slides to talk in detail what could be included in the metadata repository. The idea, just like when we process our police shooting data, we need a description about this data police shooting. We need to understand what those attributes are and where the data was collected, and how it was collected. Was it processed by somebody? So those things that describing a data set are included in metadata repository. This supports long-term maintenance and also helps a new worker coming in to understand what is in a data warehouse and how it is structured. The third layer, more and more, we're moving towards the user layer. So here we have the backend. The OLAP engine is also in the backend. It has the OLAP servers. The function of OLAP servers is to select useful, relevant piece of data from data warehouse in order to support those drill down and roll up operations. Lastly, it's the front-end tools, analysis, queries, reports, data mining applications. Here we have users sitting at here, not shown, interact with user interface to issue different queries, analyze the result, and generate different reports, and perform data mining tasks by selecting relevant data from this data set and apply data mining algorithms. Okay, so we mentioned data warehouse and the data mart, and this is relevant information that we need to understand that there's variance in terms of data house models. In a large enterprise, you typically have enterprise warehouse. There, as I said earlier, collects all the information about different subjects spanning the entire organization. So it's everything that you need to make your decision, aggregated data in data cubes and forms the entire enterprise-wide data warehouse. But it could also have data mart. When you have branches, you have departments that you could have a subset of the data that's separated from the enterprise data warehouse. and to support local decision making. So those are data marts. Both of those are physically separate storage. You could also have virtual warehouse. Virtual warehouse would be, it's different from the first two because it's virtual. It's just a set of views over operational database. Student who has relational database background understand what views are. Actually, views is just a select query. So earlier we have run, we have shown examples of select query in the very beginning of the semester. Those select queries does not output the selection in a separate table. It actually just sitting there as a virtual view. The data selected from using this select statement forms another table that's virtual that you can use this to issue additional queries. So the reason that we sometimes there is a need for virtual warehouse is because the cost. Building an enterprise warehouse, it could cost billions of dollars, hundreds of millions. It's a very expensive process. Data mart is a little bit, it's more economic, it's less costly, but still it's costly. Virtual warehouse is very cost efficient because you actually don't need to have separate storage. You don't need to create, when you have physical data store created, you have to commit to a certain schema. And that schema, once you decide, are very difficult to update, to change. So you could actually spend millions of dollars trying to make an enterprise warehouse and found that method does not work, that your result, your product does not support on a decision making very well. That millions of dollars are wasted right there. Therefore, virtual warehouse is a more economic and also low risk solution where you could just based on your operational database and create views to support additional queries on the views. And you can always change because writing data SQL statements are relatively easy as compared to a commit to a schema, organize the data surrounding those schemas. A major decision points that can be highly risky. However, the drawback, obviously, when you have virtual warehouse, you cannot, the analytical capabilities of virtual warehouse are limited because it's limited by your operational database. You can only extract data from this operational database where it has supplied those data. Therefore, the functionality can be limited. So earlier we mentioned those operations that helps to construct a data warehouse, data extraction, data cleaning, data transformation, load, and refresh. This ETL, even though it only covers extraction, transformation, loading, it does really cover, the letters indicates ETL, but content-wise conceptual understanding of ETL is it covers not only extraction, but also cleaning, not only loading, but also refresh. So earlier we mentioned metadata repository. We explained that metadata is the data that describes what's in a data warehouse. It can store descriptions of the structure of the data warehouse. the schema used for data cubes, different views that might be generated, dimensions, hierarchies, um, um, data mart locations, content, derived data definitions of derived data. So everything that's inside the data aspect of the data warehouse, you need to describe them in very much detailed level so that a newcomer joining the team actually can read this description and understand exactly what this data warehouse contains. And also, the metadata repository contains operational metadata, which contains data lineage, and the history of migrated data and transformation paths. From the source data, how do we get to this current data? Currency of the data, what's the the status, active, archived, purged, monitoring information, like data warehouse usage statistics. If error has been detected, the error reports that needs to be addressed in the next refreshment, audit trails. So those set of metadata are also crucially important to maintain the metadata, maintain the active status of the data warehouse. Metadata also could contain the algorithms used for summarization, all kinds of aggregation. Sometimes you will use more advanced statistical methods. And so those algorithms need to be documented. The mapping from operational environment to the data warehouse, where we have from the operational relational database we actually extract and convert those data into the subject-oriented data warehouse schemas. There is a mapping that needs to be done, and how this mapping is done need to be documented. Data related to the system performance, number of queries executed within a time frame. And also business data, business terms definition, those are sometimes also called business rules, ownership the data, charging policies, and all those are all documented in the metadata repository. Okay, I'm going to conclude this video and move on to the next subtopic.